In this video, we are going to write equations in slope-intercept form when we have a graph given to us. So our objective, our goal is I can write an equation in slope-intercept form when given a graph. Okay, we're writing an equation of a line. Okay, so might help us to think about, refresh our memory. What is slope-intercept form of a line? Well, it's y equals mx plus b. And it's called slope-intercept form because it's in this form here where we can quickly identify what's the slope. It's the coefficient, the number in front of my x variable. And what's the intercept, the y-intercept more specifically? That's where we cross the x-axis. Okay, so the y-axis. We're crossing the y-axis at this number. Okay, so if I want to write an equation in slope-intercept form, I know that I'm going to be in this general form here. Okay, so I'm going to set up this framework really quick, where right here is where my slope's going to go, and right here is where my numerical value for my y-intercept goes. So really, those are really the only two things we need to identify in order to write our equation. Okay, so let me start with the y-intercept, where I cross the y-axis. Okay, over here in this case, I'm just going to go ahead and put a dot right down there. My y-intercept is 0, 5. Okay, well, where I cross my y-axis, I haven't gone anywhere left or right. I've just gone straight up 5. So that's my b value here. And then my slope, to get my slope, I've got to think about, okay, this point right here, I'm going to try to find another point where I cross over a grid and kind of a nice, on a corner, a nice spot right there. And now I got to think about when I go from this point to this point, I want to break it down into how far up and down I go and how far left and right I go. Okay, so from here I go down 1, 2, 3, 4, 5, 6, 7. Okay, so I'm just going to make a note of that. I went down 7, and then I went right 2. Okay, so if I go down 7, that's a negative 7, and a right 2 is a positive 2. So my slope is negative 7 over 2. So for every change of 7 vertically, I do a change of 2 horizontally. So if you need a little bit of a review on slope and how to calculate slope, that is a separate lesson. But this is maybe just a little bit of a refresher for you. But I will remind you that when we're calculating slope, what we're doing is we're calculating a measure of steepness. How steep is my line? Okay, and you can tell as I move left to right across this page, my line is going down. This will be a negative slope. Okay, as x go, we read graphs the same way we read words. In the English language, we read from left to right. So I'm reading my graph from left to right. Okay, what's this graph doing as I go from left to right? My y values are decreasing. Okay, so this is a negative slope, so that checks out. I did get a negative slope. And we want to always be relating my change in y, my vertical change, always to my horizontal change. Okay, A lot of you have seen this equation. Slope is y2 minus y1 over x2 minus x1. If you're a formula kind of person. Okay, but on here we don't, we're not given any particular points. We're kind of left on our own to just find these points. Okay, so here's my equation right here. That's the equation of the line. All I needed was my slope and my y-intercept. Okay, next one. Again, I'm just going to go ahead and set up my framework first, right? I need to find my slope here. And I need to find my y-intercept. So those are the pieces that are missing. My y-intercept is 0, -1, so a -1 goes in here for B. And then thinking about my slopes, I've got this point right here I've already identified, and here's another point that goes nicely on the grid here. So my slope is up 1, 2, 3, 4, 5, and right 1. So up 5, right 1, I have a slope of 5. Now, if I started here and went down to this point, that's fine. I go down 1, 2, 3, 4, 5, and then I go left 1. Okay, either way, we get a positive 5 for slope. Now, I'm going to clean this up a little bit. I don't want to talk about adding a -1. I'm going to call that a 5x minus 1. And that would be my final answer there. Okay, so you have a couple of examples there that I did for you. Go ahead and pause the video. And if you get stuck, you can always start playing the video again. But go ahead and pause the video, try these two on your own, see how you do, and then you can come back and check your answers on the video. Alright, I'm going to write my equation of my line. I know I'm going to need to fill in the slope, and I'm going to need to fill in the y-intercept. Okay, so my y-intercept is 0, 4, so right here goes 4. It's the y value of my intercept here, where x is always 0 here. And then my slope, I'm going to pick another point on this line that looks like it's at a nice grid here. If you picked this one, we'll talk about, you could have picked either one, it's fine. I picked the closest one. That helps me to not have to reduce any fractions, but if you didn't see that one and you picked that one instead, I'll go ahead and do it with that one as well so you can see how we handle that. Okay, so from here to here, I go down 3, and then left 2. Okay, negatives divide each other off, so my slope is 3 over 2. Okay, now let's say we don't see this point right here, and let's say we pick this point here. So we want to think about going from here to here. I can go up 1, 2, 3, 4, 5, 6, up 6, and then over 1, 2, 3, 4. Okay, so notice that 6 is 3 times 2, and 4 is 2 times 2, so these 2's would divide each other off, and see how we still end up with that same 3 over 2 slope. Okay, so my equation, it's right here, but I'll rewrite it just for the sake of having nice tidy notes here. I like nice tidy notes. 3 over 2x plus 4. Okay, so that means for every change vertically in 3, I have a horizontal change of 2. Okay, so here's another one here. Now in this case, I have a y-intercept of 0, 0. So again, my B is just that y value here of that y-intercept. And my slope looks to be, let me pick this, looks like a point right here, a good point to pick, up 1, 2, 3, 4. Run 1, 2, 3, 4, 5 to the right. Okay, so again, I need this little framework here. My slope goes here, my intercept goes here. My slope is 4 over 5, my intercept is 0. So we'll rewrite that as 4/5 x and then the plus 0 we would just leave off. So there's my answer right there. Okay, we're going to keep going, just doing a few different types of examples that you might encounter. I actually did one just like that in the previous one. Now you might notice in all of these, my y-intercept in all of these examples is a 0, 0, 0, 0, 0. So in all of these examples, my b value is just 0. Okay, so all I really got to do is find the slope here. 1, 2, 3, 4, 1. So again, my framework for a slope-intercept form of a line is like this. I got to find my slope, I got to find my y-intercept. My y-intercept is 0, 0. My slope is 4 over 1. Rise 4, run 1. Okay, or if I started here, I could go down 4, left 1. Okay, and that would cancel my negatives off, or divide my negatives off. Okay, rewriting, my final answer is 4x. We just leave our plus 0 off. Okay, again, b is 0. Slope is 1, 2, 3, 4, 1, 2. Up 4, right 2, both positive, up 4, right 2. That can simplify to be 2 to 1, or just 2. I kind of missed that point right there. I could have gone straight to the 2 if I had seen that one, but I didn't. I saw that. Okay, it still simplifies down. And my equation is y equals 2x plus 0, except we don't really need to write that plus 0, so I'm just going to leave it as y equals 2x. Okay, pause the video, try these two, and then replay the video, and you can check your answers here. Okay, again, I have a b of 0 and a slope of 1, 2, 3, up 3, over 2, right 2. So my equation is y equals 3 over 2, x plus 0. We leave the plus 0 off. There's my equation. Okay, y-intercept is 0, so that means my b value is 0. 0, 0 is the ordered pair for my y-intercept, and I have a slope here of 1, 2, 3, 4, up 4, run 1, 2, 3, 4, 5. Oh, it looks like we already did this one. It's an extra example of the same one we just did on the previous page. Y equals 4/5 x. Okay, some other types of lines that you will see. So here we have, lines that have some countable rise and run that are different, right? The rise to the run, these are different numbers. Here we had 4 to 5, here we had 5 to 1, here we had 7 to 2, okay, here we had 3 to 2. These are a little bit different because this is a completely flat line. And thinking about slope in terms of steepness really helps me with these types of problems. Because how steep is this line? Well, it's not steep at all. The slope is 0 here. Right? It's completely flat. Slope is 0. Has no slope at all. No steepness. So then the next thing for me to do is find out my y-intercept. Okay, well that's at 0 too. So my y-intercept b value is 2. And going back to my framework, right, where I need my slope and my intercept. Okay, well my slope is 0 and my intercept is 2. Okay, well no matter what I let x value be, 0 times whatever x is, any number for x, is going to just be 0. Okay, so this term kind of gets eliminated by that 0 there. So my equation is y equals 2. And I think that makes sense if I go back here onto this line and think about all of these points on this line here, right? What do they all have in common? Notice how the y value is always 2. Okay, so that's my equation. Y is always 2. X can be a free-for-all, could be whatever it wants. Y is consistently always 2. Okay, again here, my slope is 0. There's no steepness to it at all. My y-intercept is -4. Okay, if I can think through this process again, that's totally fine, but you may be able to just jump straight to, oh, y equals -4. Okay, because again, think about this consistently, this horizontal line, even with these little points in between. Y is consistently -4. That's my equation. Okay, pause video, give these a try. Okay, on here, flat line, no steepness, slope is 0, y-intercept is -1. My equation, y equals -1. Here, flat line, slope is 0, my y-intercept is -5, y equals -5. The biggest mistake students make is they mix these up with the next type of problem that I'm getting ready to show you. And so students kind of get these confused because they're similar in a lot of ways, but they are, different. Definitely different. Okay, so notice the difference here. These were all horizontal lines, no steepness at all. Totally flat lines. Now here we have not a flat line at all. It's completely vertical. Okay, so I'm going to take just a minute and talk about slope. Probably should have done this sooner, but I want to talk about slope and what slope means. Slope, I'm trying to grab a piece of scratch paper here. Slope really is a measure of steepness. We talked about that when we started this video. It's how steep is the line. Okay? We talked about how just a flat line like this has a slope of 0. No slope at all, totally flat line, no steepness, 0 steepness. Okay, and then if I open this up a little bit, that's a little bit more steep and positive. And the more I go up, it's a little bit more steep. In fact, the more I kind of open these things up, we see that this line gets steeper and steeper and steeper. Think about the very steepest this line could be. At its very, very steepest, it's going to be straight up and down. Okay, this will be a 90-degree angle. It'll be straight up and down, a completely vertical line. And when that happens, technically, really, the slope is like infinite, right? It's infinitely steep. This number, the number we give to assign the value for slope, just gets steeper and steeper and steeper and steeper and steeper until I'm straight up and down, infinitely steep. Okay, we call this undefined slope. And in the next section, we'll talk about why it's called undefined and not infinite. Okay, but we call this undefined slope. So back to these kind of problems here, I have this infinitely steep line, completely vertical. Okay, so my slope is undefined. Okay, and I have no y-intercept. So my y equals mx plus b is really hard to talk about with an undefined infinite slope. And then also this doesn't even exist. Tears does not even exist. So what do? Okay, so I want to think about points on this line, right? These all have the same x value over here. Look at how to get to each of these points. -5, -5, 0, -5, 1, -5, 2, -5, 3, -5, 4. So what's going on here is x is consistently -5. And that's my equation for my line. Okay, come over here, next one. Let's try another one. Again, no y-intercept at all, so b doesn't even exist. Slope is undefined. It's infinitely steep, straight vertical line. But what do they have in common? Well, what's my x value here? It's 2. That's the equation for my line. Okay, let's pause the video, try a couple of these, come back, and you can check your answers. Okay, we're back. Here I have no y-intercept. We're not crossing the y-axis at all. Vertical line, infinitely steep, undefined slope. Okay, this point right here is 4, 0. 4, 0, 4, negative 1, 4, negative 5, 4, 1, 4, 5, right? These all have x equal 4. There's my equation. You're probably way ahead of me already. X is negative 4. Again, no y-intercept, vertical line, infinitely steep, undefined slope. X equals negative 4. I have attached a worksheet for you to try with some practices that also include the answers, so you can be checking your work to make sure you're doing them right. So go ahead and give that practice a shot and reach out if you have any questions.